All right, Honors Chem, this is Lesson 12 on stoichiometry. So stoichiometry is the study of conversions from the language of chemical equations to measures that we make in the real world. It's basically what allows us to use a chemical equation and to use it to figure out how much of something we're going to make, how much we need to make that something, and that's what stoichiometry is all about. So a mole, as we know, is 6.022 times 10 to the 23rd, and this usually refers to a number of atoms or molecules. So let's look at this chemical equation. It's a very simple chemical equation to create water. You need 2 H2 plus 1 O2 to give you 2 H2O. Now, the 2 hydrogen H2, it could be interpreted as molecules. 2 molecules of H2 plus 1 O2 molecule will produce 2 H2O water molecules. But of course, we've said before that molecules, atoms, are too small for us to see and to work with. So if we multiply everything in this equation by 6.022 times 10 to the 23rd, then we can read the same equation as 2 hydrogen, 2 H2 moles plus 1 O2 mole will produce 2 water moles. So it just scales everything up to an amount that we're able to see with our eyes and to measure on a scale. So we can actually see and weigh 1 mole of H2O. So the equation is speaking to us in amounts that we can measure in the real world. So molar mass. But we can't count a mole of atoms or molecules. So how do we know we have a mole? We do this by using the mass in grams of 1 mole of an atom or molecule. And here are the molar masses for some common molecules or atoms, or actually substances. So 1 mole of hydrogen atoms is 1.01 grams. Where do you get that number? It comes straight off the periodic table. 1 mole of H2O is 18.02 grams. So what you do is you take H2, you take 2 hydrogen atoms, that's 1.01, and you multiply that by 2 to give you 2.02, and then 1 oxygen atom, that's 16, so 16 plus 2.02 gives you 18.02. 1 mole of CH4, that's actually a typo, it should be 16.05 grams. Where does that come from? Well, you have 4 hydrogen, 1.01, so that's 4.04 for the 4 hydrogen, and then 12.01 for the carbon, and add those together, you get 16.05. So you get all these numbers either directly off the periodic table or by adding the masses of different elements from the periodic table. So because we can measure grams on a triple beam scale, one of these, we can calculate the number of moles. So the scale allows us to measure grams. The molar mass relates moles the equation uses to grams people use. So we can measure things in grams. The chemical equation speaks in terms of numbers of molecules. And so that allows us to communicate with the chemical equation. So the chemical equation, it doesn't care how much the hydrogen, the H2 weighs, or how much the O2 weighs, or how much the water molecule or water mole of water weighs. What it cares about is that you have 2 hydrogen molecules plus 1 oxygen molecule gives you 2 water molecules. But again, we can't count in molecules, see molecules, or deal with moles. So what we have to do is use this translator that translates from what we can do with a scale to what the chemical equation understands. And then once we've done our work inside the chemical equation to figure out what we want to figure out, we can come back out and use this molar mass conversion. It's called molar mass because it relates moles to the mass measured in grams. So we can come back, use a molar mass conversion to figure out how many grams of the substance that we were trying to make or that we were trying to use, how many grams we have. All right, on the second page of this assignment, I give you an example using H2O2 and H2O, and down below I give you the equations typed out. But I don't think that helps you because you don't see how I build these equations. You're not going to see how I build these. So what I want to do is go straight to the first problem and show you how to build these equations and how to use the graphic organizer. But you have this on the second page with all these equations typed out that you can see as examples if you would like to do that. But I'm going to skip over to problem number 1. Here it is. And what we're going to do is there's the graphic organizer, and then I'm going to ask you a series of questions. All right, so here's a reaction. It says 2 moles of Ag, that's silver, plus 1 mole of H2S is going to produce 1 mole of silver sulfide right there, and 1 mole of hydrogen gas. H2 is gas. So up here is the language of the chemical equation. Everything's in moles. What it needs is it needs 2 moles of this and 1 mole of this to produce 1 mole of this and 2 moles. It's counting numbers of atoms or molecules, or in more general sense, number of moles. Down here is our world. That's us right there. We measure things in grams on a scale. The chemical equation doesn't understand grams. It understands numbers. So numbers of particles, numbers of molecules, numbers of moles. So we need these translators. These are the molar mass conversions that tell us 1 mole of H2 gas is 2.02 grams, or 1 mole of silver is 107.9 grams. Again, you get this straight off the periodic table. There's silver, and there it is, 107.87 grams for 1 mole. Okay? The example I used in class, and let me restate it, is if I wanted to make groups of students, and I wanted to make groups of 3, and I want 1 senior and 2 juniors in each group. I don't care how much they weigh. Okay, that's irrelevant, right? I want 1 senior, 2 juniors. What they weigh is not important to me. All I know is I want a certain number of seniors, a certain number of juniors in each group. And that would make a group. Now, let's say I'm put in another room and a scale is put in my room that students can be weighed on. And that's connected to a computer in another room where I am, and I can see the readout on the scale and see how much each student weighs. But I can't see the students. So I don't really know whether I'm dealing with a junior or a senior, but I know this. I know that every senior weighs 150 pounds and every junior weighs 100 pounds. Okay? And you say, well, that's kind of a silly example because that's not really true. But in chemistry, I know that 1 mole, anytime I have 1 mole of silver, it's going to weigh 107.9. Or anytime I have 1 mole of hydrogen molecules, it's going to weigh 2.02. So that is always true in chemistry. If I have a certain moles of a certain substance, it's always going to have the same weight. So I'm just using that in my example. We're going to say that seniors all weigh 150 pounds, and I know that, and juniors all weigh 100 pounds, and I know that. So what now I'm going to do is have a student step up on the scale, and I see from my back room there on my computer that it says that student weighs 150 pounds, so I know I'm dealing with a senior. So I tell that senior to stand off to the side. Now again, I don't care what a student's weight is. I want to put a senior together with 2 juniors. But weight is the only way I have to tell whether I have a senior or a junior, is by weighing them. Now somebody else steps up, they weigh 100 pounds, so I figured that's got to be a junior. So I say, go stand over with the senior. I want 1 senior and 2 juniors. Next person steps up, they're 150 pounds. That means it must be a senior. I don't want another senior. So I tell that student to go back to their seat for a little bit. Finally, another person steps up and they're 100 pounds. I say, aha, a junior. So I tell them to go over with the group. So now I have a senior and 2 juniors, and that's one of my groups. And so that's the idea, that even though I really don't care what the students weigh, it's the only way in this example that I have to tell whether I'm dealing with a senior or a junior. The same thing in chemistry. The chemical equation wants to count 2 juniors for every 1 senior, 2 juniors for every 1 senior. But we don't have a way of knowing 2 juniors and 1 senior because we can't count numbers as big as a mole. So therefore, we put them on a scale and we say, aha, if it's 107.9 and it's silver, it's 107.9 and it's 1 mole, then that's going to be silver. Or silver is going to be 1 mole, silver is going to be 107.9. Okay, so let's go ahead then and work through this problem. These are the ones that I did in class already. And I'm going to have to move this sheet kind of up and down so you can see what I'm doing at the same time. Okay, so how many moles of H2S are required to produce 3.5 moles of Ag2S? So first question is how many moles H2S? So first of all, I'm in the moles row and I need to find H2S. It's right here. And the question is how many? So that's where my question mark's going to be. Now write these very lightly because you're going to erase them and use them over and over again. This one graphic organizer is going to be used for about 6 different questions. And then it says are required to produce 3.5 moles of Ag2S. So here is Ag2S and this is the moles row, so it's 3.5. So what I need to do is get from what I know to what I don't know. Now, even though the chemical equation is flowing from left to right in this direction, from left to right, my math equation is going to be going from here, what I know, what I'm starting with, to what I don't know. That's the way you write a math equation. What you don't know goes over on the left, what you do know goes over on the left, and what you don't know, what you're trying to find out, goes over on the right. So the first thing I'm going to write is this. We're trying to find out moles of H2S. So I'm going to come way over here on the right, and I'm going to write moles of H2S. That's what we're trying to find out, H2S. That's what the question is asking us for. And it's always unit of measure and substance. And over here on the left is what I'm starting with, is 3.5, and that's moles of Ag2S. Okay. Now I'm simply going from here to here. That's one conversion. So we need something that relates these two. What is it that we have that relates these two? The answer is it's this part of the chemical equation. It tells us that it's going to require 1 mole of H2S to produce 1 mole of Ag2S. Okay. So it's a 1-to-1 relationship, nice simple relationship. So we're going to write that over here. Okay, there's our relationship, the same thing, it's up there. If I put in 1 mole of H2S, I'm going to get 1 mole of Ag2S. Think about it. If I put in 2 moles of this, I'm going to get 2 moles of this. However many moles of this I put in, I'm going to come out with that same number of moles of this, okay? So what we can do is write this as 2 ratios. All you do is take this and put this one on top and put this one on the bottom. Oops, Ag2S. Or it's equally true to just flip it. Put this one on the top. Okay, so these are both true statements. It's just like saying there's 10 pennies for every 1 dime, or there's 1 dime for every 10 pennies. It's the same thing. They're both true statements. These are both true statements based on this up here. But only one of them is going to help us solve this problem. And it's a 1 conversion problem. How do I know that? Because there's only one box difference, 1 arrow difference between these two. Okay? So, which one do I put on top? Which one of these do I use? This one or this one? So think about that. We've asked this question in class a lot of times. I want you to get really good really quickly about how you make that decision. Okay? So the answer is we're going to use this one. Why? Because we have moles of Ag2S on top here. If there's only one level, it means it's in the numerator. It's up on the top. And we have moles of Ag2S on the bottom here. So they have to cancel out. Why? because moles of Ag2S is not in our final answer, units of measure. And in fact, moles of H2S is the units of measure for our final answer. So we want moles of H2S on the top, moles of Ag2S on the bottom. So let's go ahead and write that. And it's this relationship right here, 1 mole. Okay, so why does this work? Because this cancels with this. Notice we're not canceling any numbers. This has nothing to do with canceling numbers. It has to do with canceling units of measure. And when you cancel, it's got to be a certain unit of measure, and the substance has to be the same. You can't cancel moles of Ag2S with moles of H2S. They're different substances. So we canceled moles of Ag2S, moles of Ag2S, and now the only thing left at the end of the problem is this unit, which is what we want in our final answer. That's what you always want in the last box before you get to the final answer, is whatever the unit in your final answer is should be the one up on the top there. Okay, so that means we've got the problem set up properly. If we had used this one, we would have had moles of Ag2S on top, moles of Ag2S on top again, and moles of H2S down on the bottom. You can't cancel moles of H2S with moles of Ag2S. They're different substances. Okay, so that means this is it. So now it's a simple math problem. You multiply this, everything on top. So 3.5 times 1, and then divided by everything on the bottom, divided by 1. And of course, that just gives you 3.5. This was a really easy problem numerically, right? So what is this saying? So you're going to end up, this is your final answer. So what is this saying? The chemical equation is telling us however many moles of H2S we put into the reaction, we're going to get, on the product side, the same number of moles of Ag2S. So in this case, we put in 3.5 moles of, we actually got out 3.52 moles of Ag2S. So the question was asking was how many moles of H2S did we have to put in to get 3.5 moles? And the answer is the same number, 3.5. So both of those are 3.5. If this number had been 42, then it would have been 42 and 42. I mean, you could have picked any number. It's a 1-to-1 relationship, okay? You're going to get the same number. You put in a certain number of moles here, you're going to get the same number of moles there. Okay, let's keep doing these. The more of these you do, the sooner it's going to come through to you and not seem totally confusing and scary. Okay, so keep working at this. So I'm going to erase this. I want you to use the graphic organizer, but it's really just a work tool. It's not the final answer. Okay, so now I jump immediately to, oh, by the way, this is in bold-faced problems, I'm not going to do those for you, okay? This one is one of the tougher ones because it's grams to grams. You'll see why in a second. It doesn't mean it's really tough. It just means it's more steps. So I'm going to go to the next page. And this one is also grams to grams. So let me skip this one for right now, and we'll come back to it, all right? I could have put it in a different order, but I didn't. Let's go down to E here. So it's saying how many grams of H2 will be produced by 5.67 moles of Ag, that's silver. Okay, so let's go back here, and it's grams of H2. It wants to know how many, so that's our question mark. How many? Question mark, grams of H2. So I come down here, here's the grams row, and here's the H2 column, so the how many is the question mark right there. And then the rest of the question says will be produced by 5.67 moles of Ag, of silver. So here's moles. This is the moles row right here, moles. And we're in the silver. We're interested in silvers. So that's going to be the 5.67. So what we need to do is get from what we know to what we're trying to find out. Now, you can't do this. There's no way to go diagonally straight across in just one conversion like that. That would require one conversion to go from here directly to here. Can't do it. There's no relationship between moles of Ag and grams of H2. Now, you could go from moles of Ag through the molar mass and get grams of Ag. The problem is there's no relationship between grams of Ag and grams of H2. There's no way to move sideways when you're outside of the equation. The only way, according to these arrows here, that you're allowed to move sideways is inside the chemical equation. So the path we're going to have to take is from moles of Ag this way to moles of H2, get a number for that, and then from moles of H2 you're going to come out using the molar mass of hydrogen gas to grams of H2. So it's two steps, and I'll lightly draw an arrow. It comes from here over to here. So from moles of Ag to moles of H2, and then from moles of H2 out to grams of H2. So that's a two conversion process. Conversion number 1 to here, conversion number 2 to there. All right? So let's go ahead and get our equations set up. And I'm going to try to find a way to keep this all on the page at the same time. I think that'll kind of do it, not quite. I'm just going to have to move this back and forth. Okay, so here we go. So it's how many grams of H2. So I'm going to come over here, way over here on the left. I'm going to write grams, parenthesis, H2. And this just represents where our final answer is going to be. I'll put a little light question mark there. That's where our final answer is going to be. And then we're starting with 5.67 moles of Ag. So I'm going to come way over here on the left because you don't know how many conversions sometimes you might need. We do in this case, but because we just talked about it. But you want to leave plenty of space. It's better to have too much space than too little. So I'm going to come over here and write 5.67, and it's moles of Ag. Okay? And what we just said is it's going to take two conversions. Conversion number 1 from here to here, conversion number 2 from here to here. So I'm going to draw two boxes. And again, the first time through, I'd recommend you draw the boxes just to make this as visual as possible. Okay, there we go. All right, now down below, I should have left a little more space than I did, but down below, so I need the first conversion to get from here to here. And what is that? That's the relation of 2 moles of Ag will produce 1 mole of H2. Again, it's straight across, it's between these two. We don't care about H2S or Ag2S. We care about the 2 moles of Ag produces 1 mole of H2. So I'm going to write that right here. Okay, and then I'm going to write the two ratios. So these are both true statements. There's 2 moles of silver for every 1 mole of H2 gas, or there's 1 mole of H2 gas for every 2 moles of silver. It's just saying the same thing in 2 different ways. Those are both true statements. So think about it. Which one of these two ratios do you want to put in that box? Think about it. Think about what has to happen. Give you 5 seconds here. You can always pause the video anytime you want. Okay, we have moles of Ag here, but that doesn't appear in our final answer, so this has to cancel out. So we want to pick the one that makes this cancel out, and that's going to be this one, with moles of Ag on the bottom. So you go ahead and put this. Okay, and moles of Ag cancels with moles of Ag, and now what you have is moles of H2. So 5.67 times 1 divided by 2 would tell you how many moles of H2. Now we don't normally do this calculation, this intermediate calculation. Intermediate means in the middle calculation, but I'm just going to do it here real quick for you. And I'm just going to kind of round it. So it's about 2.84. So that's about 2.84 right there. Again, you don't normally do that calculation. But just to show you that we gotten from here to here, that's where we are in the equation right now. Now we need to make this step. We need to go from here out to here, and that's our final answer. And what's the conversion we're going to use for that? It's this. It's our molar mass conversion. It's going to get us from moles of H2 to grams of H2. And that's what we wanted to know. That's what the question asked for. How many grams of H2? Got to be sure I'm on the right problem. Okay, so here's the molar mass conversion. You just use that. Molar mass conversion for hydrogen. So now we write the ratios. And I know it seems kind of tedious to ask you to write these ratios every time. It's a long assignment, but you really have to reinforce this concept, okay? This is just a really critical skill in doing chemistry. Okay, so again, I wrote two true statements. There's 1 mole of H2 for every 2.02 grams of H2. That's what this equation says. Or there's 2.02 grams of H2 for every 1 mole of H2. That's also what this statement says. So again, now ask yourself, which one of these two ratios do you put in that box? Think about it. And the answer is this one. Now this time you have two reasons. Let's go ahead and write it first. Okay, so there it is, that one right there. So two reasons. One is that moles of H2 cancels with moles of H2. You need that to cancel out because moles of H2 is not in our final answer. But what is in our final answer is grams of H2, and that ends up on top. You want whatever your unit of measure in substance for your final answer is to be the last man standing. Okay, so that's the last unit on the top in the last box, and so you can just draw a little arrow like that. All right, so everything canceled except the thing we want to appear in our final answer. So now we're ready to do the numbers. So it's going to be 5.67 times 1 times 2.02 divided by 2 divided by 1. So let's go ahead and do that. And we get 5.73, and 3 significant figures is good. 5.73. Okay, just rounded up to 7.3. So that's 3 sig figs. We have 3 sig figs there and there. And remember what we said in class. This is called a standard. We want to know that 1 mole of H2, what does it equal in grams? So we want to know what exactly 1 mole equals. So we're just assigning this to be exactly 1. So that's an infinite number of significant figures, as you're not limited to 1 significant figure. You could call that 1.00000 forever. This is the measured value. This is the amount that's measured. Your periodic table gives all the values to 2 places after the decimal, but there's some periodic tables that'll give you the values to 4 or 5 places after the decimal. So this is the measured value. This is the one that limits the significant figures. This does not limit significant figures. So we can go to 3 significant figures because of this and because of this. All right? Okay, there's your answer right there. Okay, let's keep going. How about F? How many moles of H2S are needed to produce 6.8 grams of Ag2S? So what I'm going to do is erase what I wrote before and write it very lightly. And in the future, I'm not going to do the intermediate calculations. We're just going to set up the equation and go straight to the final answer. Okay, so how many moles of H2S? So I come up here to the moles row, and there's H2S in the moles row. So that's my question mark. It's asking how many are needed to produce 6.8 grams of Ag2S. So I come down to the grams row, and there's Ag2S, there's grams, so it's right here. So it's 6.8. Okay, so again, we're going to start here. Even though the chemical equation is moving from reactants on this side to products, the math equation is moving from this number back to this number. Okay, we're trying to figure out what we need of this to get this much here. Okay, so how many conversions is that? Well, we got to start here. We use the molar mass conversion for Ag2S to get the number of moles of Ag2S. And then we work from moles of Ag2S to moles of H2S. Remember, you can only move sideways inside of the chemical equation. You can't move sideways down here. So it's here to here and here to here. So let's go ahead and set up the equation, the math equation now. So it's going to be moles of H2S, so I'm going to come way over here. And we're starting off with 6.8 grams of Ag2S, so that's way over here. Again, math equation, you always start on the left and end up on the right. Okay, and how many conversions did we say? How many steps did we have to do? We had to go from here to here, that's one conversion, and from here to here, that's two conversions. So it's a two conversion problem. So we're going to go ahead and draw two boxes. There we go. Okay, so let's get started. So the first conversion is going from here to here. That's the molar mass conversion. Anytime you're going in or out of the equation, it's going to be the molar mass is going to be your conversion, the molar mass conversion. So it's 1 mole equals 247.87 grams of of Ag2S. Okay. So now we're going to make two ratios out of this, okay? Hopefully some of this is becoming kind of okay, like rote, like you're getting tired of doing it because you get it, but that's what I want. I want you to say, I get it, okay, over this. Or you flip it. Okay, so once again, I have two ratios that are both true statements. This over this or this over this. Those are both true statements. So again, think about it. By now, I want this to start feeling a little more natural. Which one of these two do you want to put in here? Well, if you chose this one, you're correct. You need grams of Ag2S on the bottom to cancel with grams of Ag2S on the top. Okay, so grams of Ag2S cancels with grams of Ag2S, okay? So we've taken care of that one. So now where are we on our graph? We're now inside this box. We're not going to do the calculation, I just said that. You don't need to do the intermediate calculation, but that's where you are right now. Now we need to move from here to here, and what's our conversion going to be? It's going to be this one, again, okay? The relationship between moles of Ag2S and moles of H2S. All right, so, and we see that it's 1 and 1, so we're going to go over here and write this. Okay, and we're going to write two ratios. I'm going to put a line here so we don't get these confused. So that's a true statement. I'm going to scratch this out so it doesn't get us. Okay, so again, two ratios. One of them goes in this box. Which one is it going to be? Going to be this one. Why is it that one? Because we need moles of Ag2S on the top to cancel with moles of Ag2S on the bottom. Since moles of Ag2S doesn't appear in our final answer, we had to make it cancel. And what does appear in our final answer here, the units of measure, is the last man standing right there, the very last unit on the top in the last box that leads to that. So now that we know we've got our cancellations and everything set up right, we're going to multiply 6.8 times 1 times 1 divided by 247.87 divided by 1. Okay, and of course, as you know, you don't really have to multiply by the ones, but technically everything on top, divide by everything on bottom, right? Okay, and that gives us this. And how many sig figs can we go to here? Well, you got 5 there, but you only have 2 there. So it's going to be limited to 2. So I'm going to have 0.027. So that's 2 significant figures. The leading zeros are not significant. So you notice that the significant figure thing really isn't that complicated, because you're almost always doing multiplications and divisions. So you just have to look for the number with the least number of significant figures over here, and it's this one. So that's how many that your final answer can have. And that's a decimal. It doesn't look like one. That's a dot. Okay, so there's your final answer for that. Okay, a lot of writing. Now you're going to get to the point in the future when you get good at these, and when I don't demand that you write all of this stuff, where you don't have to write all of this out like this. You could just be able to look at it quickly. You're still going to need to set problems up like this. Trust me. You're not going to get to where you can do the more complicated ones in your head. You're going to have to set them up. Again, the answers here and here are not important to me. It's that you're setting up the problem like that. That's what I want to see. And may not get much of any credit if you don't do it this way, okay? Don't be stubborn and think I'm just going to scribble down a calculation. That's not working for me, because it won't work for you. Okay, now let's go back and do some of those grams to grams ones, okay? Let's do this one first. So B, let's see, B we're going to skip because it's bold-faced. That's one you're going to do by yourself. So let's do one that's just like it. It's a grams to grams, okay, up here. Grams of H2S to produce grams of Ag2S, all right? So what you can do is, before I even go to the graphic organizer, I can go ahead and write out the equation. That's what you'll get to where you start doing. Grams of H2S, so way over here. Grams. So that's where your final answer is going to go. And way over here on the left is what you know. So and this is going to be 3 conversions. So I should have even put that even closer to the edge. You're going to need every bit of space you can get on your page. So it's 8.3 grams of Ag2S. Okay, now you said, well, how do you know it's 3 conversions? Well, I know, but you don't. So now I'm going to show you how. Let's go over to our graphic organizer. And I'm going to erase. You don't have to see me erasing, that's okay. Okay, so we start out with 8.3 grams of Ag2S. So here's Ag2S, and here's grams down here. So this is going to be 8.3 grams of Ag2S. And what are we trying to get to in the question? Grams of H2S. So here's grams again, and here's H2S. So it's going to be some number, some question mark. That's what we're trying to find. Now, it would be nice if we could just jump from this box straight across, but there's no relationship between grams, no direct relationship between grams of Ag2S and grams of H2S. So we're going to have to go from here up into the equation. You can only move sideways in the equation, so we're going to go from here to here, then from here to here, and then back out from here to here. So that's 1, 2, 3 conversions. So we're going to need 3 boxes. Going grams to grams is 3 conversions. So here we go. Okay, 3 boxes. Wow. And again, I'm going to have to start writing way over on this edge, because I can promise you it's going to stretch over to that edge. So the first one we need is to get from grams into moles inside the equation. So that's going to be the molar mass conversion, that one right there. And way over on the side of the paper. What is it? 1 mole of Ag2S for every 247.87 grams. Whoops, I didn't write my equation first, so let me do that. But when you get good at this, you'll skip that too, and you'll just go ahead and go straight to the ratios. Okay, so there's the equation, now the ratio, and then we can reverse it and do the other ratio. between. Okay, it's going to be really tight on space, so I'm going to go ahead right away and draw a line right there. Okay, so which one of these two goes in there? Hopefully this is starting to be automatic by now. You need to get grams of Ag2S to cancel because it's not in the final answer. So we're going to use this. Okay, so here's grams of Ag2S and grams of Ag2S gone. Alright, so right now if we did this calculation, we'd come up with some number for that number of moles, but we're not going to do that. We're just going to keep writing the equation. So now what's our next step? We need to get from here to here. What's the conversion to get us from here to here between these two? What relates these two? And it's one we've used several times already. It's this right here. Okay, inside you're just using the relationship of moles to moles. So I tell you what, I'm going to save some space and I'm not going to write the equation of 1 H2S equals 1 Ag2S. I'm just going to go straight to the ratios here, because otherwise I could run out of space here. So it's going to be 1 mole okay, those are your two possibilities. So which one goes in the second box here? Okay, the answer is this one. It's got moles of Ag2S on the bottom to cancel with this. Okay, so moles of Ag2S cancels with moles of Ag2S. And now if we were to run this calculation here, we would be in this box right here. Now we're ready for our last conversion to get us from this box out to our final answer down here, and that conversion is the molar mass conversion. I think I can fit the equation up here. Okay, so now we're going to write the ratios. Okay, two ratios. Which one goes there? Well, we need moles of H2S to cancel out, and we need grams of H2S to be on the top for our final answer. So it's going to be this one right here. Okay, so moles of H2S cancels with moles of H2S. Everything is canceled except what we want for our final unit. That right there, and that goes over there. So that means we have our equation set up correctly now. All right, so now what? So now you multiply everything on top, 8.3 times 1 times 1 times 34.09, divided by everything on the bottom. Divided by 2.47.87, divided by 1, divided by 1. So let's go ahead and do that. And what we get is 1.14. And how many sig figs here? We can only go to 2 sig figs because of that. So I'm going to call that 1.1. And that is your final answer. That's how many grams of H2S you will get out if you put in 8.3 grams of Ag2S. Or I think it's the other way around, right? Over here, sorry. Yeah, that's how many, it's how many grams of H2S you would have to put in order to come out with 8.3 grams of Ag2S, okay? The one thing to notice about this is just a lot of multiplications and divisions. There's no really deep math in this. It's all multiplication division stuff, okay? All right, what else do we have on this one problem? Nothing, that's it. So problems B and D are for you to do on your own. Okay, guys, I'm just going to give you a heads up. We're going to take all day on Wednesday and Thursday, depending on which period you're in, to work on these, okay? There's a lot of problems, but it's really 2 lessons. That's why it's a 100. If you look at the front page, it's a 100-point lesson, okay? It's 2 lessons, really. So we really want to take our time with this and nail this down because it's really important. Okay, I'm going to break this video off, and I'm going to do the other problems on additional videos. I'll do them a little bit faster as you get the hang of this a little bit, but really focus on how this is done, and let's get this assignment done this week, okay? All right, so I'll see you on the next video.